continuation of the preparation of dienes, let us look into the stability of the conjugated dienes. And the conjugated dienes, as I said, they are highly stable. What makes it this much stable is the subject of discussion for today's presentation. One of the factors which is responsible for this high stability is due to resonance stabilization or due to conjugation of the pi electron system. I take a diene as an example, and the pi electrons, as they overlap sideways, the pi electrons moves towards one carbon, and once these electrons moves towards this carbon becomes electron rich, and it gives rise to a carbene ion, and which I represented as minus, which shows it is electron rich. As these electrons are moved towards the first carbon, from the carbon where it has moved, this electron it has lost, that's why it becomes electron deficient. To satisfy this electron deficient center, or to satisfy the electron deficiency of the adjacent carbon, pi electrons from the adjacent carbon moves towards this carbon. The pi electron shift from this position to the adjacent position. Once this shifts, what happens? These electrons have moved. Its valency is satisfied over here. It becomes C double bond C. As these electrons are moved over here, this become electron deficient. That is represented as plus. But however, these are canonical forms, or we call it as resonance hybrids. And these are intermediate status. None of these are permanent because they have positive and negative center. Again, this electron rich, the pi electrons moves towards this positive center. Once this moves, what happens to this carbon? This becomes positive, and to satisfy the positive center or the positiveness or electron deficiency of this carbon, the electron rich carbon gives its electrons back to this carbon. And then what will I get? The same starting material. It is electrons, what we have is like money which should be distributed. And once it is distributed in the system, the total system becomes stable. Resonance stabilization is one of the factors which is responsible for high stability of these conjugated dienes. There is another factor along with this resonance stabilization which is responsible for this high stability of the conjugated dienes. Before that, we look into this. Because of this resonance stabilization that we see in these conjugated dienes, they become more stable. As they are more stable, their delta H, heat of hydrogenation, is less. They have lesser energy. In case of conjugated dienes, delta H is found to be 54 kilocalories per mole, whereas in case of isolated dienes, it is around 60 kilocalories per mole. And cumulated dienes where two double bonds are attached to the same carbon, it has 70 kilocalories per mole. Let us look into the other factor, that is because of the lower hybridization energy. In conjugated dienes, we have two double bonds separated by a single bond over here. The pi bond is formed because of the overlap of the p bond or the p electrons. This p orbital is perpendicular to the other orbital. The overlap of these electrons in the p orbital, it gives rise to pi bond. And the carbon in the alkene is in sp2 hybrid form. As this carbon is in sp2 hybrid state, the bond between this carbon and this carbon, which is attached through the sigma bond, it becomes shorter and stronger. The bond length, carbon carbon bond length in alkanes is found to be 1.53 angstrom units, whereas here it has reduced to 1.47 angstrom units. That's why hybridization energy is again decreased, and this adds to the stability of this conjugated dienes. Whereas in case of non-conjugated dienes, carbon with single bonds are in sp3 hybrid form. That's why the S character in this sp2 hybrid carbon is more. As S character is more, it is more nearer towards the nucleus of the carbon. Hence, they are more attracted to each other, and hence the bond length decreases. One is due to low hybridization energy, which is attributed to the sp2 hybridized carbons present in the diene. Another is conjugation of these two double bonds by resonance stabilization. These are the two factors which increases the stability of conjugated dienes. Because of this increased stability, they have more type of or more varieties of reaction. What are this reaction? What are their products? Will be the subject of discussion in the coming presentation. Till then, have a nice day.